Hello everyone and welcome to another edition of SQL Server 2022 Tips and Tricks Best Practices. In this installment I wanted to talk about best practices regarding the security best practices. Okay, so in the first video I covered like the basic best practices that you should actually apply, and now we're gonna check out security best practices. So I'm gonna once again go to my notes and check where we're gonna start. So first of all, the first best practice of security is gonna be actually data encryption. So enabling data transparent data encryption (TDE) to then encrypt data at rest. So this is what we're gonna do. We're gonna enable TDE on our database. Okay, so first of all, we're gonna need to create a database that we are gonna be working on. So this is gonna be just a test database that I'm gonna create for the purpose of implementing all the security things. Okay, so let us actually create the database. So basically it's gonna be just called salesdb. I'm gonna have a couple of tables. So these are the tables that I'm gonna be also using in this salesdb. Just a couple of them, and they have like basic data like email addresses and phone numbers. So we have let's say sensitive data here in our database. Okay, so now let's go to TDE and we're gonna implement. So let's do a new query. Okay, and I think I also had another document where I had a little bit of information about transparent data encryption. TDE is a feature in SQL Server that helps secure the database by encrypting the entire database at rest. It ensures that the data files are encrypted, thus protecting sensitive data from unauthorized access in case the physical storage, such as hard drives or backups, is compromised. Okay, so basically this is TDE. So we're gonna start gradually. So first we're just gonna use master. Now we're gonna create the certificate that is gonna be needed for TDE. So first we're gonna need to actually create a master key in the database. Okay. Okay, so let's do this once again. And let's actually create a database master key if it doesn't already exist. So it doesn't exist here, so we're gonna first we need to actually create a key with a password. I just specified a random password here. Okay, now we can actually go back to creating the certificate. Okay, now we have the TDE certificate. I think if we can check in our security credentials, maybe I'm just gonna refresh everything. Database, salesdb, security certificates, and for now we don't have anything here created. Okay, with subject your certificate name. So basically actually maybe specify the certificate name, just TDE, let's say. Okay, and now let's see. So we got the certificate and the key covered. Okay, create a certificate in the master database. Okay, so this is done. Switch to the database you want to encrypt. So in this case we are gonna switch actually to SalesDB because that's the database I want to encrypt. So I'm switching to this because we were actually working on the master database where we were creating here. That's the thing, I forgot about it. Sorry, the certificate is here, TDE. I'm just gonna delete this one. So here's our TDE certificate that we created on master database, and now we're switching to SalesDB because that's our main database that we want to encrypt and protect. Create database encryption key. So here we go. I'm gonna create, of course, using SalesDB. In my case, in your case, probably something else. Okay. Sorry, TDE certificate. All right, so it's gonna be called just TDE in my case. Okay. The certificate used for encrypting database encryption key has not been backed up. You should immediately back up the certificate and private key associated with the certificate. Okay, so basically after actually creating the encryption key, we are suggested to back up everything, just to be sure. So we can now enable TDE encryption on the database. So we're gonna, of course, enable. Once we have the encryption set, we can enable it on our SalesDB. Okay. And now we can verify the encryption status. So we can actually check if everything went like it should and if our SalesDB is actually encrypted now. So we can check, and 1 means that it is encrypted. If it was set on 0, it would mean that it's not. So everything went as expected. Our SalesDB is protected by TDE, but we still didn't back up the encryption. We didn't back up the encryption key. Okay, so basically, if we want to back up our TDE certificate and the key, how it was actually suggested after we created both of those, you can use this query. So we need to use the master database, and then we can back up the certificate that is called, in my case, TDE, and we specify where the certificate needs to be backed up, in my case on an E drive, and here we have the TDE in a SER, and we got the private key as well, and we need to specify the password for the private key. So this is how it actually looks. And we can go here, can check on our E drive, my SQL backups. We should actually have both of those. Okay, and let us do this once again. Let's check, and there it is. Okay, so basically I probably won't needed a moment. So we got the TDE certificate and our private key as well. If we go here, we go to the details. So yeah. Okay, so basically this is TDE, how you can implement it into your database, how you can encrypt and protect your database with the certificate and private key, and backup both of those. Okay, let's see what's next. So next thing after that, we got auditing the database activities. So enable SQL Server auditing to track and log sensitive data activities. Okay, so basically to do it, we're gonna run this query. So let us do a new query here. So enable auditing for logs for logging attempts on MasterDB. So basically it's for MasterDB, but it can be, as you can see, server audit for SalesDB, so for my database of course, and it's gonna be in SQL audit. So I need to actually create this folder because I don't have it probably on my C drive. So I'm just gonna create a new folder. It's gonna be called SQL audit, and there we have and it's gonna log in all the it's gonna actually keep all the failed login attempts. So this is basically what the audit is gonna do. Okay, so if we go here to the C drive as SQL audit, and here it is, right? Okay, so that's how you can basically start with auditing. What do we have next? So performance tuning and best practices now. Okay, so let's go on through this. So basically what you can actually use on your database is query store. So enable and configure query store to capture query performance over time and help with query tuning. Okay, so we're gonna enable this. So this is what we are gonna be doing right now. So we're gonna be enabling query store. Let's actually do this. Now if we go to databases, SalesDB, we should have query store here. Yeah, there we go. Okay, so query store is enabled. Optimize index strategy. Add appropriate indexes on frequently queried columns to speed up data retrieval. Okay, so based upon my database, because basically all of the queries are based on my database, add an index on an email column in customer tables for faster lookups. So basically what I'm doing right now is adding this index. We can take a look once more. Let's actually take a look upon all the tables. Customers, okay. I think I didn't copy something here. Okay. Still missing something. Products, orders, order items. So maybe let's try it like this. Okay, so let's try maybe customers. Okay, so customers. Probably he has some kind of problem with this query with the customers. Okay, well, Let's check. Let's check this one. Order items. Okay, so yeah, I forgot that I need to actually use the query here. SalesDB, sorry about that. New query. My mistake. I was on master probably, that's why. Okay, and okay, so wait, just to verify indexing stuff. Yeah, add an index on email column. So basically email column that we have, right? So I'm just gonna scratch this. Let's go back here. And I'm just gonna add this. Okay, successfully, great. So, and add an index on product name in products for quicker search. So basically, this is best practice implemented into my SalesDB right now. Those both of those indexes, and we can actually take a look once again. Okay, so what's next after indexing? We can use memory optimized tables. Okay, so we're gonna stop for a moment here because this is another huge thing that you can use. It really improves performance of your SQL Server. So SQL Server offers in-memory OLTP online transaction processing to create memory optimized tables. These tables are designed to provide high performance for OLTP workloads by storing data in memory rather than on disk. So we got here steps. Steps to set up the memory optimized tables. Enable in-memory OLTP feature. OLTP feature is automatically available in SQL Server 2022 for all editions, but the database must be configured to support memory optimized tables. Create a memory optimized file group. Before creating memory optimized tables, you need to create a special file group to store memory optimized data. Okay, so these are the steps that we are going to take. And the other thing, because you can either choose the option of creating the optimized the memory optimized tables, or you can choose the option of setting up persistent memory. So PMEM persistent memory PMEM allows for faster data access by passing the traditional I/O subsystem and directly accessing non-volatile memory devices. Okay, so basically you can either choose this option or the previous one. We are gonna go with the first option here. And okay, if you expect high transaction volumes, consider using memory optimized tables for frequently accessed data. Create a memory optimized version of the products table. So basically we're going to be basing it on add a memory optimized file group to the database. Okay, so we are working on our SalesDB all the time. Add a file to the memory optimized file group. Okay, so second step, alter database. So we're working on SalesDB. Add a file, my name, my memory optimized file. So let's just call it maybe optimize or something like this. Okay, file name. Let's call it optimize, and it's gonna go to SQL data. So you need to actually check if you have everything right. So as you can see, I don't have this created on my E drive, so I need to create this folder. Okay, new folder, SQL data. Okay, right. We can go to SQL data now here. Optimize, file stream. Okay. Okay, next step, create the memory optimized table. So now we're going to be creating the memory optimized table. So basically in 3 steps, create the table. And there we go. So basically in 3 steps we were able to tables, right? I'm gonna go to security here also. Just for a moment, I wanted to check the certificates. Sales DB, okay. Product memory optimized, DBO products memory optimized, okay. Okay, fine. So basically, there we have, this is how you actually create memory optimized tables. So in this example, like it was said here, a memory optimized file group was added to the database. So my self DB was altered, and add a file to the memory optimized file group. File has been added, and then the database was created for optimization. Okay, so this is how you can set up the persistent memory PMEM. So I'm gonna actually under the video I'm gonna also I'm gonna try to link, maybe I'm gonna try to paste those things about PMEM, how you can actually create and use it. Okay. PMEM. Okay, next thing for best practices, we got changing the temp DB location. Okay. So if you didn't know, you should know that your temp DB should also reside somewhere else, not on the main disk. So let's see. Okay, so at the moment my temp DB resides on my C drive. So MDF and LBF are residing on the C drive. So I want to change this. I'm just gonna copy here. Let's run. We're gonna just go here to the data. Okay. So tempdb, MDF, LDF files, they are residing here. So what we're gonna do, we're gonna actually alter the paths. I'm gonna alter the paths. Okay, so it's gonna go to SQL data. So once again, remember that you need to have this created previously. Okay, so okay, The file tempdb has been modified in system catalog. The new path will be used next time the database is started. Okay. Okay, we're now gonna modify the same thing for the log. Tempdb log. Okay. Execute. Sorry, SQL log. Yeah, wasn't created, so we need to actually create the folder here. SQL log, and now we're gonna move it. Okay, should be fine now. SQL log, and now what we need to do, of course, we need to go to the SQL Server configuration, and we're gonna actually restart everything. Okay, everything has been restarted. Now we can actually go back here, and we're gonna once again use the tempdb. And now we can actually check the new path. So our tempdb, MDF and LDF, so log and data, now reside on the E drive. The SQL data and SQL log. Okay, so that's another best practice that you should actually apply to your SQL Server. And now, once the tempdb has been moved, we can actually go to optimizing your tempdb. So configure multiple tempdb data files to reduce contention and improve performance. Determine the number of CPU cores. It is recommended to create one data file per CPU core to avoid contention. First, determine the number of CPU cores in your SQL Server instance. So we need to actually check how many CPU cores we actually have dedicated here. We get 8 CPU cores. Create multiple tempdb data files, recommended one per CPU core. Right? So I'm just gonna create a couple of them. Okay, let's try it like this. Okay, now we're gonna create another one. Another one. And fifth one. Okay, so now I should have in total, let's see, data. So I got 1, 2, 3, 4, 5. Okay, 5. Great. Check file growth and size. You should also configure the tempdb data file to have proper auto growth settings to avoid fragmentation and unnecessary performance overhead. A good rule of thumb is to set a reasonable growth size. Okay, so basically this is how you actually set it up. So auto growth. Okay, so basically I'm just gonna check it like this for all of those, and there we go. Okay, next thing in our journey to actually use the best practices. Now we got maximize parallelism. Configure the max degree of parallelism, max DOP, to optimize the parallel execution of queries. That can be very helpful. Set max DOP to a balanced volume, 4 or 8 for most systems. Okay, so basically I'm gonna use 4 here. Just in case. And there we go. Configuration option, max degree of parallelism changed from 8 to 4. So on the default I had it set to 8, and now I changed it to 4. And because I have like 8 cores, I could of course set it to 8 queries. I just change it now to 4. But this is actually how you can reconfigure this option. Okay, I think if it goes to best practices, so I think I'm gonna conclude this video because it's running quite long now. So this is part 2. Part 3 coming up, and in part 3 where we are gonna check how you can actually create a SQL Server cluster, failover cluster. So we're gonna be doing failover clustering, implementing this, and also doing the replication on both servers. Okay, so once again, if you like the content, like and subscribe, and I will see you in the next